Hi everyone, my name is Rishi Gupta. I am a rising senior from the US. I'm actually in the Pacific time zone, so it is 1 a.m. right now, but I'm super excited to be sharing my research on retrospective analysis of inflation and recency bias in US elections. So for a brief introduction, I do want to introduce a couple of concepts. The first and probably the most important is recency bias. It is a cognitive pattern where people weigh recent events more than older ones. Now, this concept is heavily present in politics, but there's no quantifiable measure or precise time frame for this qualitative concept. I mean, how do you define how recent an event is? Now, to understand this in a political context, we can pair it up with another concept called retrospective voting. This is when voters evaluate incumbent candidates or parties based on their previous performance. Now, when exploring recency bias, it's really important that we explore it with respect to a particular topic. And the topic which I chose was inflation, because inflation and the general economy is something that voters generally think about a lot when voting. And in order to represent inflation numerically, I found the Consumer Price Index, or CPI. This is a numerical measure that is a strong proxy and quantitative indicator of economic wellness. Now, with these three, I could explore how recent is recent and go on my way to quantify recency bias, which is super important so that we can refine campaign timings, policy rollouts, and media strategy. So this leads me to my two research questions. The first one being, what is the quantifiable time frame during which inflation-related events, as measured by CPI, significantly influence voter behavior and electoral outcomes in US elections? Now, due to the time that I was given, I will not be able to cover my second research question as I didn't want to rush my explanation of what I did and the results. Therefore, I'll be focusing on my first research question, but the second one will be included in the paper that I write. Now, starting off with the methodology, here is the software and the computational framework that I used. So I used Python and my environment was Jupyter Lab notebooks. And I used five main libraries, them being Pandas for data manipulation, PyReadar for reading the .r data files, NumPy for array computing, stats models for statistical models, and building them and working with them. And finally, scikit-learn, which was used to give me machine learning metrics, which were really important for me to understand what my results were and how to interpret them. Now, starting off with the data source selection, I started off with probably the most popular elections, the presidential elections. I found this data set from Harvard Dataverse, and alongside the presidential elections were also the senatorial and gubernatorial elections. However, I didn't use these two elections because there's a really big complication. They were not held on a regular uniform schedule, and instead were scheduled at different times based on the respective state. This is really important because I'm trying to match the elections with the CPI data based on the particular year and month. And if the years and the months are completely different, then it's a lot harder for me to compare the two metrics. And a possibility could have been that I manually go through each and every senatorial and gubernatorial election, and I label what month and what year it occurred to match it with the CPI data. But this is super prone to errors, which is why I refrained from that, doing that, and instead went to house elections. Now, house elections happen once every 2 years, and they're, for the most part, on a pretty regular basis. There are a few exceptions, which I will mention later in the slides. Um, These house elections were also found from Harvard Dataverse. And finally, for the Consumer Price Index values and data, I got that from the US Bureau of Labor Statistics. Now, starting off with the presidential elections, I took the county level data that was provided to me and aggregated it to a national level for each election year. I had three main parties that I was working with, which was the Democratic Party, the Republican Party, and the third party, which I just categorized as other. And for each party, I computed the margin of victory as well as the party's vote shares. And through the margin of victory, I was able to identify a national winner, as well as the incumbent and the incumbent's margin of victory. Now, a really key thing I want to emphasize was I decided the winner based on the popular vote, not the Electoral College. Now, for presidential elections, the Electoral College is used to determine who is the winner of the US presidential election. However, I decided to use a popular vote because I felt that this was more representative of the general view on certain candidates or parties, especially since the Electoral College has a winner takes all policy where it doesn't matter if a state maybe has like 60% one party and 40% the other party, all of the votes go for the majority party, which I thought was not very representative of the general population, and therefore I used the popular vote instead. Now, for House elections, things were a lot more complicated, so I'm going to take this step by step. I first started with the party normalization by taking all the variant descriptors for parties and write-in names. So, for instance, for the Democratic Party, a common alternative was the Democratic Farmer Labor, which is just like an extension or like a branch of the Democratic Party. So I had to make sure that I collapsed everything to three simple parties that I mentioned before, which was the Democrat, Republican, and the other, which is just any third or any external party. Now, for the timing filters, this is where I talk about how there were a few exceptions for House elections not happening on a regular schedule, and this was for primaries and special elections. I had to remove these due to the fact that there were inconsistencies with the timings, and I ended up removing 15 total elections across 3 years, 1996, 2006, and 2018. And an example of this would be North Carolina District 9 in 2018, where there was a re-election done in 2019. And due to this gap of a year, I decided to remove it from my analysis so it wouldn't cause any complications. Now, some more things which I had to address, one of them being runoff elections. And this is really important because it's slightly different than special elections. So for runoff elections, I retained only the runoff votes because these were the ultimate decider of who won the election. An example being Louisiana District 5 in 2002. However, this differs from special elections because runoff elections typically have the same candidates. They're very close to when the general election happened, whereas special elections can happen a year or two later. And they typically also have different candidates. So for runoff elections, since the general view of the candidates or parties is relatively the same, I decided to keep those even with the slight change in timing. For fusion tickets, I merged the votes for multiple party endorsements for particular candidates. For instance, New York, it's very popular that a particular candidate runs under more than two or three parties. So what I did was I compiled all the votes for the candidate into one, and I took the party, which was the majority, and that was the party that the candidate was representing. Finally, I had to address ballot accounting. This was not something which I necessarily had to change, but something important to note. The first is the total votes includes non-votes and write-ins. So this includes blank votes, scattering, void votes, undervotes, overvotes. And while they do consist of a very small minority of the total votes, it's important to note that I included this because this is what actually happens in US elections. And it's super important that we just don't remove these and we actually address them so we get a more realistic view of the connections with recency bias. The other thing is for any uncontested races, they were counted with one vote. And this was just meant to be a token vote for weightage so that there would be a representation of the seat being won without significantly influencing the total votes won for that party. Now, after doing all of this initial cleaning, I had to further clean the data. And what ended up happening was I had district level data with each row representing a unique district in a particular year. Each row had the total votes per party, it had the names of the candidates, and also had the respective geographic identifiers. And using this, I was able to calculate the margin of victory, the winner, the incumbent, and the incumbent's margin of victory. just like I did for the presidential elections. However, here's where there's a slight difference. For the presidential elections, I mentioned how I only used the general popular vote, and I did not use the electoral college. For the House elections, I did also use the total votes, but I also decided to use the number of seats won. And this is because for a state, you can have two or more parties that win specific seats for one particular state. And it's different than the winner takes all system of the electoral college, which is why I decided to include it in my analysis. Now, for today's presentation, I will only be comparing the total votes for the presidential elections and the House elections. The last thing in terms of the data is the CPI data. So the actual values of the CPI don't matter a whole lot because we are more concerned with the change in CPI. And the four intervals I decided to take were 1 month change, a 3-month change, a 6-month change, and a 12-month change, rounded to 3 decimal places. Due to the time frame of the CPI data, I had to make a couple of adjustments. So for the presidential elections, they were initially 1872 to 2020, but I had to change this to 1916 to 2020 because the CPI data was only available starting from 1930. And for the House elections, there was no change needed to be made, so it starts from 1976 to 2022. In terms of the statistical modeling, I first created panels. Now, the panels which I created were for each month and for each CPI change. So not only did I take this 4 CPI change intervals, but I also decided to look at when that change starts from, what particular month. So what that means is elections happen typically around November. So I took a 1-month change, a 3-month change, a 6-month change, and a 12-month change from November. But what I did was I also changed this starting frame to October and looked at the 1 month, 3 month, 6 month, and 12-month change in CPI with respect to October. And I went back all the way to June. And the reasoning behind this was because I was curious to see whether there is a constant time frame that is important or whether there's a specific month that is important in terms of having the most influence or importance with regards to inflation-related events. Now, in terms of the two models that I used OLS regression, which is ordinary least squares regression, and I examined the CPI's effect, or the change in CPI's effect, on the incumbent's margin of victory. The second model I used was logistic regression, where I predicted the incumbent's margin of victory based on the change in CPI, where 0 represents the incumbent winning the following election, and 1 representing a defeat. Now, for the results, I'm going to start off with the presidential OLS regression. And the key thing which I want to talk about here was that the OLS regression did not work to the best as I thought it initially would. As you see, the highest R-squared value out of all the data is 0.254, which is super less. And therefore, all of these values aren't very significant. It's modeled to where we would like it to be, and therefore I did not use much or any of this data at all. However, for the logistic regression, it provided a lot more information, which I will be talking about. So the first thing which I want to talk about are the coefficients and the odds ratios. These are noted by the colors, the columns that I highlighted. And essentially, the green represents a positive correlation, and remember, the positive correlation just means that it's more correlated with the incumbent losing the election. So based on the trends, we can see that when we are much farther from the presidential elections, we tend to see the general view of the incumbent losing the election. There are more positive views for the person who is against the incumbent. However, when we get closer to the elections, we tend to see a slight change where the incumbent gains more popularity. And this is the previous is mainly due to the fact that retrospective voting exists. and the latter is due to the fact that you start to have presidential campaigns, and with the legitimacy and the credibility of the incumbent, it usually tends to have a lot more weightage. Some other things which I do want to talk about are the fact that you had a high precision and a low recall. As you can see here by the averages, the high precision means that the model was very successful in terms of logistic regression. It was very successful at finding losses. However, the problem was it was not able to find all of the defeats of the incumbent, which is why it had such a low recall. Now, for the odds ratio, I had already talked about this, where the incumbent was more likely to win closer to the election, and it was more likely to lose farther away. In terms of the significance, pretty much all the values, all the p-values were above 0.05, so the results here are just suggestive and not conclusive. In terms of the model's bias, we tend to see a very high accuracy because a model tends to predict that the incumbent party will win, which is why the accuracy is super high, and that's why I did not solely look at just the accuracy to make my decisions. But just from general results and looking at all three, the accuracy, the precision, and the recall, we can see that pretty much the 3-month mark before elections is when inflation-related events have the most significant impact on voters. Now, this does extend to 6 months, but anything after that is insignificant. So pretty much like the 12-month mark, that's already too far, and voters aren't really thinking about that. For the House, we had a similar thing as the presidential, where the R-squared values were just so little, where I didn't feel comfortable basing my entire conclusion or my results on this data. But we can see that the R-squared values are slightly higher than the presidential. I still included the data just for visibility, but I did not use this to form my results and conclusion. However, for the logistic regression, we see a very interesting trend where the coefficients are all negative. So the model is super in favor of the incumbent winning. We also see this from the odds ratio. And another thing we see is the fact that there is a super high recall this time and a lower precision. Just showing the data again, this is a flip from what we saw with the House data. And this is mainly due to the fact that the model for here was able to find all the defeats, but it kind of overextended itself, indicated by the low precision, and it just predicted the incumbent to lose a lot more. That's why we see, even though we see an odds ratio of negative, which means that the model is generally predictive of an incumbent winning, it predicts extra losses where it shouldn't have, which is why the precision is a lot lower. In terms of significance, we do actually see some p-values being below 0.05. Just going back here, we see like this value over here for the M11, so November 6-month logistic, that's below 0.05. For the October 6-month logistic, we also see below. So we can see that some of the values are below 0.05. So some of the results can be conclusive in this instance. However, the results are pretty much the same as the presidential, where the 3-month mark is like the most optimal mark. However, we can extend this to 6 months in terms of the most significant time frame, but anything after that is just insignificant. So now just some concluding statements. Around the 3 to 6 month mark is when inflation-related events have the most significant impact on voters' decisions. And we were able to quantify recency bias, which is super great. And it really rethinks our definition of how we define recent, especially heading in. I thought recent was a month or even less than a month, but now we can see that recent definitely expands a lot more to include 3 to 6 months prior to an election. I do also want to address a couple of limitations with my study. The first one being that inflation was the only proxy used. Obviously, when voters make their decisions. There are a lot more factors that go into that. And inflation is not the only metric to determine the economic status of the country. So future research could involve using more factors other than inflation. The next one is the fact that I excluded the Senate and gubernatorial races. That could be something which future studies address, where they manually label each election and they go through it. And finally, the rigid change in monthly CPI intervals. I took 1 month, 3 months, 6 months, and 12 months, but it would probably be more helpful for future studies to look at the in-between values. So for instance, like a 2 month change, a 4 month change, and so on. For acknowledgements, I'd like to thank CCIR for giving me the opportunity to conduct and present my research. I would also like to give a huge shout out to my mentor, Dr. Francisca Tang, who really helped me a lot with this project. And without her, I would not have been able to get nearly as close to where I am today. And here are my references. Thank you for listening to my presentation. And now if anyone has questions.
Thank you, Rishi, for a great presentation and a very good conclusion at the end. Maybe I can start the questions off and ask, what did you find the most challenging part of this research project to be?
Yeah, that's a great question. I think the challenge was definitely looking through all of the House results. Just because there are so many specific things with House elections that you have to worry about compared to presidential elections. For presidential elections, typically you have like a Democrat or a Republican winning. But for House, you have to keep in mind that there is third parties and there are third party candidates that do win. So just managing all of that, looking through all the data, making sure that I'm addressing different elections and looking into the specifics of them, I would say was probably the most time consuming and the most challenging part.
Great, thank you so much. Is there any questions from the attendees? Okay, I don't think there's any other questions. Thank you again for your time today. And also for, I know it's a very early time in the morning for you, so thank you so much for somehow being awake and ready to present. Thank you very much. And for your research and your time into the project.
Yeah, thank you so much.